Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit doing another AIME practice problem. This is because the AIME one is next week, February 1st, that is next Thursday. Reminder, some of the basics, 3 hours for 15 questions. We have numerical answers, integers from 0 to 999. And if you want to learn more about that, check out our All You Need to Know blog post with all of those details there. We're going to focus more on a hard problem from last year. It's not too tricky once you know the idea and once you settle down into the pattern of coming up with the solution. But let's take a look. Alice knows that 3 red cards and 3 black cards will be revealed one at a time in random order. Before each card is revealed, Alice has to guess the color. If she plays optimally, the expected number of cards she guesses correctly is m over n. So we're looking for this expected number of cards she guesses there. Now, before we start, let's talk quick about this Alice plays optimally business here. And what does this tell us about her strategy, right? What could we say about the strategy in this case? Well, I just want to mention here that the key thing that we have is if there is a tie, let's suppose she guesses red, right? Otherwise, she guesses the more likely card there, whichever one is more likely. So let me maybe say what else, the color that is more likely in that case. I do want to bring this up because it's important to be consistent. It doesn't matter. You could say, well, what if she guesses black? That's fine too, right? If it's equally likely for the tie, you guess black, that's okay. But we have to be consistent when we're going through our cases, when we're going through our strategy there. Of course, she could do like half the time she guesses red, half the time she guesses black, but that just makes it needlessly complicated when we're doing a problem. So let's look at an example here to start. And I want to think about the strategy that we just kind of thought about here. So what is an example and what is something that could happen? Let's just do a scenario where maybe it's red, black, 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 red, red. Let's look at kind of a scenario like this. So this would be our sample outcome. And let me kind of just go through our strategy and what we would guess, and then we can count how many she got correct in that case. So first one, there's 3 red, 3 black remaining, so Alice's guess is going to be red, and that one is correct in this case. So we can go back and see which ones are correct, incorrect there. Now, next guess is going to be black because the first card was red. Now we have 3 black, 2 red remaining. Black is more likely, so Alice bets black there. Now we have a tie. We said on a tie, Alice guesses red. So now we have 2 reds left, 1 black left. She guesses red again. That is unlucky for Alice, but that's what happens sometimes. Now, there's only red remaining, so she guesses red 2 more times in this case. Now, let's go through and count the number correct then. First guess was correct, second guess was correct, third and fourth were wrong, and then fourth and fifth were correct. So in this scenario, she got 4 correct guesses there. Now, one strategy that definitely works is you could list out all of the outcomes. So there are 6 choose 3, 20 outcomes. Hey, by symmetry, we don't really care whether stuff starts with red or black, so we could do some strategies to narrow down the outcomes that way as well. right? What would happen if we flip stuff around? Similar things would happen there. So maybe with some symmetry, you could narrow things down to a smaller set of outcomes. Regardless, it's not too horrible to list out the outcomes, go through what we just did, count up how many correct in each case, and take the average. That's definitely a strategy that we could do and we could think about there. Now, let's do a different method. We're going to think slightly differently here with how we do it, and we're going to use something that's called conditional expectation. So our strategy, we are going to use conditional expectation here. If you've heard about conditional probability, this is pretty much the same type of situation here. And it's oftentimes a little bit harder to teach. It's something that's not taught as much, because to do formal calculations with this or to formally explain everything, it gets a little bit tricky there. But the idea is the same as conditional probability. So I will erase the tree in a moment, but remember, we can use this tree to help guide us there a bit, right? So the idea here is, right, either we're going to guess red, right, or guess black at each scenario there. And then what's going to happen? Well, right, if we're correct, and maybe let me just kind of talk about this as one box here, right? So if we are correct, right, we have one more correct guess, right? So we plus one to our correct table there, to our correct guesses, right? And then we can think about repeating with less cards. So we have fewer cards in that scenario there. So we can repeat everything going on in that case as well. So that's going to be our strategy for coming up with some of these formulas and things like that there. Now, the other thing I want to mention here is we do want to assume, and we can assume, some symmetry things in this case. So in this scenario, then, a couple of things we want to do. So let E of kind of R comma B, we could use different variables, equal to, right, the expected with R red and B black, right? So pretty self-explanatory here. And one thing that I want to mention, and is worth mentioning quick, is that we do have some symmetry here. So I'm not going to use R and B for a second, but the expected number, if you have some number of red and some number of black, the expected number of guesses correct in that scenario is the same if we flip things around. So that kind of shouldn't matter what, if there's 3 red and 1 black, that's equivalent to 1 black and 3 red as far as this expected number is concerned. And then our kind of magic here, and the reason I want to mention this symmetry, is our key equation then is, well, what if we want to know what's the expected number of guesses here with R red and B black cards? Now, symmetry is important because without loss of generality, let's assume that red is greater than or equal to the number of black there. And this actually is very important because it cleans things up in terms of, by our strategy, we now know that Alice is guessing red. So she's guessing red. What's the probability she's correct? That is R over R plus B. Now, in this case, she's correct, so she adds 1 to the number correct. And If she's correct, this means we saw a red card. So there's a R over R plus B chance we see a red card. This means Alice is correct. So she got one correct, and now there is one fewer red card available for the rest. There is a B over R plus B, or 1 minus this chance she's wrong. Just for clarity, let me put the 0 there. And now we have the expected number of guesses with R and one fewer black card in this scenario. So that's our setup then here. And in a sense, our problem is pretty much done at this point. But just to kind of make things clear, let's make a table and start calculating these values. We'll do a couple of them with some work, and then we'll speed some up in the interest of time to help things go a little bit faster there. So let's make our table of values in this case. And we can think about these with our red and black cards. So we have red cards, we could have 0, 1, 2, or 3. And for our black cards, we could have, of course, 0, 1, 2, or 3. Now, couple of notes there. We do have the symmetry along the diagonals that we're going to be taking advantage of. Other things we know. Well, what happens if there is 0 of one card? If there is 0 of one card left, we know, or Alice knows, that all of the cards are the other color. So we can fill in 0, 1, 2, 3, 0, 1, 2, 3 in those cases, right? If there's only red cards left, Alice is going to guess red. If there's only black cards left, she's going to guess black. Things like that there. Now, like I said, let's show some work, and then I'll erase this to make room for a few of these boxes. So what about this box here? How could we calculate this box in this case? This is E of 1, 1, right? So if we look at E of 1, 1, I'm not going to write out our full formula, but what we have here is, okay, we are going to have 1/2 times 1 plus 1, right? 1 plus E of shifting over 1, this one there. We're always going to be dependent on the two values to the left and the right in this case. So we have 1/2 times 1 plus 1, 1/2 times 0 plus 1. So we can pretty easily here say, okay, in this box we have a 3/2 there. Now, what if we kind of do something similar moving on, right? So let's move on to a different box here. What if we want to find now E of 2, 1? We can use the same formula, right? So in this case, there are 2 red, 1 black. So there's a 2/3 chance Alice is correct. And now we get rid of one of the cards that are red. And so we have 1 and 1 left. So we shift up to this 3/2 scenario there. Otherwise, we shift with a 1/3 chance, 0 plus shifting left. So we have a 2. And so if you do this calculation, 3/2 times 5/2 plus 1/3 times 2, we are going to get 7/3 in this case. Now, right, just to mention the symmetry at this point, right, if we think about the symmetry here, we now know that, okay, this 7/3 for the 1, 2 scenario is exactly the same. And now we can keep building up from here. So for the next box, right, what is this box here? What is the 2, 2 case? Well, we have 1/2 times 1 plus 7/3 plus 1/2 times 0 plus 7/3. If you do this calculation, you get 17/6. And then we continue building up the rest of the table. So I'm going to save a little work here. You use the exact same formula. 13/4, okay, by symmetry, this is 13/4. 18/5, by symmetry, this is 18/5. And then finally, we get to our bottom corner, which is the one we need, 41/10. So our guesses here are going to be our answer, right? The expected number for 3 is 41/10. And so m plus n is going to be 51 here. If we want to have that final answer, it's going to be 51 in this case. Now, like I said at the beginning, if you want to say, oh, this is a mess, I would have rather listed out the 10 by symmetry or 20 total outcomes and gone from there, that's fine, right? I'm not saying this is the definite best way to do this, but this idea of conditional expectation is very helpful. This conditional expected value is a very helpful thing to keep in mind. That will do it for this video. Stay tuned for a next problem next week. Good luck on the AIME to everyone who is competing. And if you have comments, ideas for future videos, let us know below. Otherwise, thanks for watching, and I'll see you all next time. Goodbye.